So we just wanted to let you know that for the next few classes, we're going to be, the topic-wise, we're going to be covering, jumping to chapter 10. And in particular, we'll be focusing on 10.1, 10.4, and 10.5. We are skipping 10.3 for now. We'll be coming back to it later. But I am actually not going to be focusing too much at all at any time on 10.2 because 10.2 is the distance between points in a solid. We've actually been doing questions like this already, and this is where you might need to calculate the distance between two vertices in a solid, or the distance between a vertex and a midpoint, or whatever. And basically, in order to do this, you need to be able to identify right angle triangles and use the Pythagorean theorem. And we've already been doing a lot of that, so I'm not going to be actually teaching, so to say, that chapter. We've really covered it already. If you feel kind of still not sure about what those kind of problems might be, then it's a good idea to go to 10.2 and try some of the problems there. All right, we have quite a bit of notes today, but the notes are really for you. So I'm going to speak pretty fast. If you don't have time to write down the notes, then I suggest you pause the video and copy the diagrams down. Right? When we're talking about 3D shapes, there are basically two types of 3D shapes. One are right prisms, where you can see what happens is there is a face. Let's say this is a cube. A cube is a square on one end, and then it's almost like you stretch that square to make a 3D shape. In the cuboid, you could have another square that you're stretching even more, or you could have a rectangle on one of your faces that you're stretching, right? A right triangle prism obviously is a triangle that you are stretching, so to speak. It's like a Toblerone, right? Like that chocolate box. Pentagonal prism, you have a pentagon, right, that you are stretching. There are three types of shapes. I lied. The second type of shape is a pyramid. And a pyramid is, right, I think all of you, if I drew this pyramid, all of you would be like, oh, yeah, I know what that is. But pyramid doesn't have to have a square base, right? So sometimes you might have a rectangular-based pyramid or a hexagonal-based pyramid, right? And when they say blah-blah-based pyramid, they're talking about the shape of the base. So here the base is a rectangle, here the base is a hexagon, here the base is a triangle. The most important thing is that all of those sides come up to be in a point. What's also important is that the cross-sections parallel to the base of a pyramid are the same shape as the base, but different sizes. A cross-section is when you kind of cut across a shape and look at the section that you get. Right, and here's the last type of shape that we'll be working with for 3D shapes, which is solids with at least one curved face. So we've got a sphere. A hemisphere has two faces, one plane and one curve. Remember that hemi means 1/2. We have a cylinder and a cone, right? In math studies, we only study right cones, right? In a right cone, that means that the height is going to be perpendicular to the circular base of the cone. One of the words that you may not have encountered before that's really important is the difference between vertical height, which is usually what we mean when we say the word height, and slant height, right? And slant height is a distance from kind of the top of the cone to the edge of the base. Okay, so this is the slant height. And then this h that we usually would call height is technically the vertical height. Okay, so here's the first thing that we're going to be learning with 3D shapes. So in this lesson, we're going to cover surface area and volume of 3D shapes. Here is a surface area. right? So surface area of a solid is the sum of the areas of all of its faces, and surface area is measured in square units. So cm squared, meter squared, right? Many of you on the last test lost points, really easy points, because you didn't put the units. I checked with Mr. Hillman, and he said that the IB usually has like one question where they are really strict with units, and most of the other questions are not, but they'll always have one section or one question in which if you don't have the units, you don't get the point. So since you have no idea which question that is, it's a good idea to always write units with your answers. Okay? And I also suggest this is a really, really good advice, right? To calculate surface areas, first sketch the solid. So here they have the solids sketched for us. So let's just I'm going to just work through some of the surface area questions, right? So here we are calculating the surface area of these solids. If you look at shape A, basically we have three different types of rectangles, right? We have the rectangle that is 2.5 by 3 centimeters, right? So the area of that, of course, is 2.5 times 3, and there are two of them, right? There's one on the bottom, and there's one on the top. So I'm going to then multiply that again by 2. We have another rectangle, right? One of the faces of the rectangle is right here and over here, right? And that rectangle, of course, is 3 by 5, right? So that's a 3 by 5 rectangle, and again, there's two of them, so I will do that. And then last but not least, there is another rectangle over here. Sorry if all these colors are confusing you. Right? So another rectangle over there, and then that rectangle is the same as 2.5 times 5. So 2.5 times 5, and again, there are two of those. So what you would just do is you would do all of this, and you would add it all up, right? And when you do that, you would get 70. Okay? Now, we don't want to just write 70 because that doesn't have units, right? This is centimeters, so the area would be 70 centimeters squared. Right? Let's look at B. I'm fairly sure that the IB will never ask you, like, draw a rectangular tetrahedron, but in case that helps with this. They're probably more likely to call it this, right? So if they say, draw a triangular base right pyramid with all edges 5 centimeters, you need to know that it's talking about this shape. You'll see a word here that says right pyramid. That just means that if you draw the vertical height, right down to the base, your vertical height, then that height will be perpendicular to the base. That's what right means. Just like a right triangle means something with 90 degrees, a right pyramid is the height is 90 degrees to the base. Right, so here's our triangular base right pyramid. All the edges are 5 centimeters. Right, so think for a moment right now how many faces, right, how many sides this triangular base right pyramid has. Okay, so this pyramid has 4 sides. Okay, all of the sides are triangles that are 5 by 5 by 5. Right? So how do we find the area of that triangle? You could do it if you wanted by trying to figure out the height of this triangle. You could do that, definitely. Another way to do it is, and if you want to do that, you can do that. I'm not going to do that. The way I'm going to solve it is I'm going to say, well, this is a equilateral triangle because each side is equal, and so each angle is equal, right? Which means that each angle must be 60 degrees because it's 180 degrees divided by 3. Well, I know that if I have a side, and an included angle, then I don't have to deal with any sort of square roots or things like that. And then of course there are 4 of those, so I'm going to then multiply this whole thing by 4. Okay? And if you do that, then the area that you should get is, corrected 3 significant figures, is 43.3 square centimeters. Right? There's a question about what significant figures are. Significant figures are if there are 3 numbers. If you have 3 distinct numbers, then that you probably have 3 significant figures. All right? It doesn't necessarily mean 3 decimal places or 3 numbers after the decimal place. But if you do have 3 numbers after the decimal place, then it's a good way to check that. It's a good way to make sure that you have at least 3 sig figs. Okay, let's talk about this. I'm going to go through this pretty quickly. This is just for you to write notes. Alright. Right, so surface area of solids with at least one curved face. We've got surface area of square. This is the formula booklet. We've got a cylinder. Right? Now, cylinder is tricky because a cylinder has a circle, and then it has kind of a curved area, right? And the only part of, right, so the curved area, if you unfold it, becomes a rectangle, okay? And the only part of the formula of the surface area for a cylinder that's in the formula booklet is the area of the curved surface. So please be aware of that. They don't actually have the formula for the total surface area. Now, to get this total surface area, all you need to remember is that, well, if I have the curved surface, then the thing that I have remaining are 2 circles. Right? You know this is pi r squared, and this is pi r squared. So, the formula for the total surface area of a cylinder is 2 pi r h plus 2 pi r squared, but this is not in the formula booklet. So make sure that you're not just using that formula, you're really thinking about what you need. Similarly with a cone. So a cone has a circle as a base, and then it has kind of that, that part that curves around. The area of the curved surface is in the formula booklet. However, the total surface area is not, but of course all we have to do is to just add the base to it. And since the base is a circle, the total surface area is pi r L plus pi r squared. Once again, L is the slant height, which means that it's this length right here. Okay? Again, remember, this is not in formula booklet. Okay. So let's just do a couple of examples for surface area, right? I am actually not going to just calculate the area of the curved surface, we're just going to do the total surface area. So, this is for each of these solids, calculate the total surface area, right? The first one is a cylinder. So, if it's a cylinder, I know that it has 2 circles and then a curved surface. Right? The 2 circles, of course, is going to be 2 times, because there's 2 of them, times pi r squared. Now, r is, of course, half of the diameter, so r is going to be 2.5 squared. Right? There are 2 circles, so it's 2 times pi times r squared, and then for the curved surface, right? We know that that formula is going to be 2 pi, here, let me write this first, 2 pi rh, which is equal to 2 pi r is of course still 2.5, and h is going to be 4. Okay? So all we have to do is to add this and this together, and then the total surface area, so I'm going to add those 2 together. And so the total surface area is going 2 square centimeters. Again, if it's area, it's always going to be square centimeters. Let's go on to B. Right, so if you remember, and I'm going to actually kind of skip a little bit and say, hopefully you remember from your notes that the total surface area, and I'm going to write SA, right, total surface area for a cone is equal to 2. Equal to pi r squared, that's my base, right, plus, plus pi r L, okay? So I'm going to just plug in the whole thing right away. So that's going to be equal to pi, and again, in this case, they actually tell us what the radius is, it's 6, so it's going to be pi times 6 squared plus pi times 6 times, and this is the tricky part, L. L is not 8, because 8 is the vertical height, not the slant height. So I'm going to take a pause for a moment here, right? This is exactly the type of tricky question they'll ask, and I'm going to think to myself, wait a minute, if I look at the triangle formed by kind of, if I like a cross section of the cone, then I have a 6 here, I have a 8, I have a 6 here, I have an 8, that's my vertical height, and the part that I really want to figure out is this right here. Right, so how can I figure out that slant height? So the way that I'm going to figure out the slant height is by using the Pythagorean theorem, and if you do that, then you should get that this slant height is equal to 10. Alright, so that is the number 10 that I'm going to put into my formula, right here. So once I calculate all of that, I put that into my calculator, I should get 302 square centimeters. Okay, moving on to volume. So this is the last section. I'm actually not going to do any practice problems. It's just for notes for you to write. But I think this is really, really important. I wanted to draw these pictures. I particularly suggest that you draw like this one in your notebook. Why? Because actually you should draw that one and you should draw this one. Alright, so the volume of a solid is the amount of space it occupies, blah, blah, blah. But to calculate the volume of a prism, you need to know the area of the cross-section and the height, okay? Cross-section means basically the end face. Okay, this is a good way to think about it. So you need to know the area of the end, and you need to know the height, which is the distance between the two end faces. Okay? So when you look at, for example, this one right here, you should not think to yourself, oh, the base here, the end face is the rectangle. It is not the rectangle, right? Because this shape is not the same rectangle size all the way through. The end face of this prism is this triangle, because if you cut this prism into little pieces, right, kind of parallel to this, you will keep getting this triangle. I don't know if that makes sense. Right? And the height is the distance from one end to another. Okay? So in general, this is the only formula for a prism, only formula for volume that you need to know that helps you figure out the volume of like all of these shapes, which is it's the area of the cross section times height. The way to think about that also works for a cylinder, right? Because in this case, our end face is the circle, right? The circles right here, right? So you would just get the area of one of those times the height. All right? The only things that are different are these three. All right? The volume of a pyramid. I just realized I said all right a lot in this video. Okay, anyway. The volume of a pyramid, right, which is 1/3 times the area of base times vertical height, volume of a cone, and volume of a sphere. All of these formulas are in the formula booklet, so you can write it down now, but they're also in the formula booklet. And we're done.